Okay, let's continue with the trig functions of angles in a standard position. Alright, let's explore a couple of things. Let's suppose that we want to find out what the sine of 30 degrees is. Let's draw that. First, where is 30 degrees? Well, first we need to know. So 30 degrees, just remember your quadrants again. Quadrant 1, 2, 3, and 4. Okay. So 30 degrees is quadrant 1. I'm going to call it Q1. Okay. And what is 150 degrees? Well, that's in quadrant 2. Is that okay? Yeah, very good. All right. So what are the values? What is the sine of 30 degrees? Well, here is the thing. If you go to the calculator and say sine of 30, so 30, and I'm going to punch in sine, and I get 0.5. Is that okay? So 0.5. Now, let's see what happens when I punch in sine of 150 degrees. 150 sine again. Ooh, we got 0.5 again. Now, how come? So let's explore that. Let's draw the standard position angle 30 degrees. And here is 30 degrees right here. Approximation, okay? And where is 150 degrees? Okay, let's do the 150 degrees. And on 150 degrees will be like that. Okay, so this would be your 150 degrees. Now, can you see a relation between 150 and 30 degrees? Well, here's the thing. What is the reference angle to 150 degrees? Well, the reference angle is right here. What is the measure of that angle? Well, that measure is 30 degrees. And remember from previous section, when you create that right angle triangle using the terminal arm as its hypotenuse and using the x-axis, you are creating a triangle in quadrant 2 with the reference angle to the standard position angle 150 degrees. And because of that, you're in the second quadrant. Because of that, both values are the same. Now, to get the exact value, you need to know two things. One is the standard position angle, which reference goes to the reference angle. The next one is what quadrant the angle, the standard position angle is. So look at the second piece. When we look at the second question, so sine of 30 degrees, we know that's 0.5. And if we draw a terminal arm, here it is, that's 30 degrees, and that's straightforward. Where is 210 degrees? But 210 degrees is in third quadrant. This is the third quadrant right there. So I am going to draw 180 plus 30, that's approximation. It's not exact, but that's what that is. And this is the standard position angle, 210 degrees. Great. Now, what is the reference angle to the 210 degrees? Well, the reference angle is the angle between the terminal arm and the x-axis, and it's acute, okay? And that is 30 degrees. Great. But you're in quadrant 3. Values of x is negative. Values of y is also negative. Okay, so we got negative y down here. So if you got a coordinate here point on the graph, on the line, and you create that diagram, that triangle, using the terminal arm and the initial arm, or the x-axis as the part of that triangle, you notice that when you do this, your ratio, and this is your hypotenuse, okay, so you have a negative y here, this is your negative x, which is the value, and when you write the hypotenuse, the formula for hypotenuse, you're going to get a negative value because opposite is negative y, so this would be negative y over the hypotenuse. Have a negative value, and now the answer will not give you 0.5 anymore. It will actually give you negative 0.5. Let's give it a try. Let's go to your calculator. You punch in 210 degrees, trigonometry, do the trig, punch in the sine, and you get negative 0.5. So the value the value, the actual quantity is the same. It's just that now it's either positive or negative, and depending on what quadrant you're in, and depending on what value for each of the coordinates you have, you'll get a negative value or a positive value, and that applies to all the other coordinates. Okay, so in quadrant 1 you have both values positive, and then you go to quadrant 2, quadrant 3, quadrant 4. So look at this diagram. Let's write up all the ratios for each of the quadrant and then go from there. So first quadrant, both x and y positive. Let's call this r or hypotenuse, doesn't matter. We know that they're both positive. So sine, cosine, and tangent in here. So sine of theta would be y over r. Cos of theta will be y x over r. And tangent of theta will be y over x. Notice that everything is positive. So we say in quadrant 1 all ratios are positive because they are. Okay, and the angle is an acute angle. Great. Let's go to quadrant 2 and 3 and 4 and do the same thing. So we're in quadrant 2. So this is the standard position angle now we have, okay, theta. And because of we have in quadrant 2, we're going to draw the triangle again. All right. So now this is the reference angle we're dealing with, but you can actually say that's the same as theta, so you can write it up. Now remember, second quadrant, we have y is positive, x is negative, okay, and this is your radius. Excellent. Go through. So sine of theta equals to y over r, cos of theta equals to minus x over r, so cosine is negative, and tangent of theta is y over negative x. That always makes it negative. So tangent and cosine negative in quadrant 2, sine is positive. We do the same thing in quadrant 3. Here is the standard position angle right there, but we're using the reference angle which is right there only. So create a triangle again. All right, in this case y is also negative and x is a negative. So if you write that, so sine of theta, this is in quadrant 3 now, even though we're using theta, but we're actually using the reference angle to theta is minus y over r, cos of theta is minus x over r, and tan of theta equal to minus y over minus x, and then that will end up being y over x. And now notice that sine and cosine, the ratios will be negative, right? Right here, sorry, right there, that's negative. All right, and negative value, and then cosine is also negative. So you got negative here, negative there, so these two guys are negative in quadrant 3. And the very last one is the quadrant 4, and this is the standard position angle, but what you're going to use is just the reference angle right here, and we're going to use this triangle right there, and let's find out what is everything. So in this case y is negative but x is positive. So if we write up all the ratios, sine of, let's say, the new theta, let's call that theta nicer, here you go, new theta here. So sine of theta is minus y over r, and that's the radius is always positive, or hypotenuse. Cos of theta is x over r, cosine is positive, and tangent of theta is minus y over x.